Okie dokie, today I'm talking about the lac operon. This is a type of inducible operon and kind of the main example for an inducible operon. One thing I wanted to go over that I forgot last time was that operons are only found in prokaryotes, and we kind of should know this because we're going to have interaction between molecules around the DNA, and DNA is only open in prokaryotes. It's not open in eukaryotes. Eukaryotes has that nuclear membrane, an envelope in that nucleus to protect the DNA. But in prokaryotes it's different, just kind of floats around in there. And so the lac operon, once again we have our regulator, this is our repressor protein, and we have our gene and our terminators, so just the same setup as up here. But what's going to happen is we're going to start with a high lactose environment. So I'm going to use lactose, the lac operon, lactose. So if we have a lot of lactose around, and I don't know what it looks like, so I'm just going to draw it as a circle. So in the cell there would be a high amount of lactose. And so then what this lactose would do, the lactose is going to be that inducer molecule. So lactose, that is the inducer molecule. And what the inducer is going to do, as we know because of our knowledge on inducible operons, it's going to cause that conformational change in our repressor protein. And so now we can see here that the repressor protein has fallen off, and we have our RNA polymerase bound on the promoter. And in this one, where it wasn't bound, and the operators and the repressor protein is still bound to the operator, the RNA polymerase can't copy it. But here, because it has fallen off, RNA polymerase is going to be able to go and copy this gene. And what this gene is going to do is it's going to give us some mRNA, and that mRNA is going to make a lactase enzyme. And so what this enzyme is going to go do now is go break down all of the lactose. Break down lactose. And as the lactase breaks down the lactose, this inducer molecule is going to get broken down. And so then once there's no inducer molecule, then the repressor protein will bind back to the operator. The reason the cell would want to do this, or the prokaryote, is because if the environment doesn't have a high amount of lactose, then there's no need to be making a bunch of lactase enzymes. So when the lactose is low, then we don't make no production of lactase. But when the lactose is high, then we make the lactase. So it saves the cell energy from having to make this enzyme all the time when it doesn't need it. But when it does need it, all that has to happen is for the lactose to bind onto the repressor protein, and then that enzyme is going to get made. And so that's kind of how the inducible operon works. It keeps it off to keep the cell from wasting energy, but then when it is needed, it can turn on and start coding for the genes to make the proteins that you need. And so that's kind of an example of the inducible operon and the lac operon. I hope that was helpful.